Hi there. Today we're going to start section 4.3, which is on combining functions and then also on compositions of functions. So we may break this up into another two-part video. One, we'll do the combining functions first, and then we'll look at compositions in part two. All right, so we're going to start with just the basic four operations of functions: adding, subtracting, multiplying, and dividing. So at the top of your notes, you'll see the function notation and how that works. So basically what this says is if you have two functions added together and they're both in terms of x, then you can break them up individually, find those values first, and then add those together. Same for subtraction, same for division, multiplication, and same for division. Okay, so basically it's just saying you can treat each function individually, work out the problem, and then you'll get your result. Also today we're going to talk about finding the domains of all of these things. So the domain, which is real important on these operations, you have to look at the domain of the function f and function g, so separately, what are their two domains, and then you also have to take into account the domain of the result. And then all of that together will give you your answer for the domain. You kind of have to look at what it all is combined together. Okay? All right, so look at example 1. This example is giving you three functions. Function f is a square root function, function g is just linear, and function h is a rational function. So we're going to use these functions in parts A, B, and C, and then write our results, and then find the domain. Okay? All right, so we're going to do function f divided by function g of x. So remember that we can take f of x and then just divide it by g of x. And that's what that says to do. All right, so f of x is the square root function, 2x minus 1. And g is x minus 9. So this is a good one to start off with. There's no simplifying to do. That is your answer. You can't divide a radical by a non-radical, so that's our answer. Okay? But what's important here is the domain. So we need to look at the domain of f of x, the domain of g of x, and then the domain of the result. Okay? So we need to look at all three of those things before we can list our final answer of the domain. So look at f of x. Okay? This is a square root function. So remember, to get the domain of that, I'm going to put it up here a little bit, you have to take what's under the radical and set it greater than or equal to 0. Okay? So if you solve that, you're going to add 1 to both sides and then divide by 2. So we end up with x is greater than or equal to 1/2. Okay, so we have to remember that as we're writing our final answer. Now look at g of x. Okay, g of x is just a polynomial up here, so the domain of that is just all real numbers. Okay. And now we have the result. Okay, so in the result we have the radical, but now we have the x minus 9 in the denominator. So we already have this taken care of. It's right here. Okay, but we didn't take care of this. So remember, we're not allowed to divide by 0. So we also have to say that x minus 9 can't equal 0. Right? We can't have that. Even though up here it was fine, now it's not fine in the denominator. So x cannot be equal to 9. Okay? All right, so our answer is going to be all real numbers greater than or equal to 1/2. That has to be true, but I also have to take out 9. Okay? So that would be from 1/2 greater than or equal to, so including 1/2, and I'm going to stop at 9, and then I can take 9 out, and then I start back up again at 9, and I can go all the way to infinity. Okay? So you have to look at all of your pieces before you can get your answer. Okay? So again, yes, it was all real numbers, but I also had to think about this, so that's my now starting point, and I had to take that out. All right, now let's look at b, g divided by f of x. So again, we're going to take g of x and just divide it by f of x. So same exact problem, we're just flipping it around. So now the x minus 9 will be on the top, and now the square root of 2x minus 1 on the bottom. Again, there's nothing I can do to that, so that's that. But now I've got to look at my domain again. So we need the domain of g of x. I know we already did this before, but I'm still going to write it down. The domain of f of x and the domain of the result. Okay. All right, so g of x we already talked about. Domain was all real numbers, right? I'm not going to do those over, but I'm just going to rewrite them. Domain of f of x we already talked about. X has to be greater than or equal to 1/2. Now that's from just these individual functions, okay? Now we have to look at the result. So this is our result. So now this is fine, it's in the numerator, but this cannot equal 0, okay? So all I can have here is that it can only be greater than 1/2, not equal to 1/2. Remember, when it's in the bottom, you take away that equal part. So the result is just greater than 1/2, okay? So if I look at all of these, I've got to combine those all together to the ones that work, and so my answer is going to be right here. The values of x have to be just greater than 1/2. Can't be equal to 1/2 because that would give me 0 in the bottom. So my answer for this one is just 1/2 to infinity. Okay, so much different result depending on what's in the numerator and what's in the denominator. All right, now we're going to look at C, which is g times h of x. So we're going to do g of x times h of x. Okay. So g of x is x minus 9 times h of x, which is 1 over 2x squared plus 3. All right, so if we multiply those together, we're going to just, this is in the numerator, remember it's over 1. So x minus 9 times 1 is just x minus 9, and the denominator will stay the same, 2x squared plus 3. All right, so there's our answer. Okay, so again, we need the domain of g of x. We now need the domain of h of x, and then the domain of our result. Okay? All right, so we already did g of x, all real numbers. Okay, now the domain of h of x. Well, h of x has 2x squared plus 3 in the denominator. So this is a fraction, so we'd have to see, is there anything that'll make this equal to 0? Which there is not, but we'll solve it anyway, but this does not have any problems. But remember, we would take 2x squared plus 3 and set it equal or not equal to 0 and solve. So when you do that, you're going to get x squared can't equal negative 3 over 2, right? You're going to move the 3 over, it becomes negative, divide by 2, okay? So then you would take the square root of both sides, and you can't take the square root of a negative number, so this does not have any solution, okay? So there is no number that'll make that equal to 0. So the domain of h of x is also all real numbers, okay? So now all I got to worry about is my answer. Well, the top is fine, the bottom is fine, we just realized that, so there are no problems, so I can use any number. So the domain of this is also all real numbers. So that would be my final answer. All three don't have any issues, so the result would be all real numbers. Okay? All right. Let's do a couple more of these. All right, so example 2, we're given two different functions, and we're going to find each of the, well, we're going to find f minus g of x and then also the domain. All right, so f minus g of x, remember, just means to take f of x and then subtract g of x. Okay? So f of x is x over x minus 3 minus g of x is 2 over x minus 5. So we're going to have to get a common denominator. So we're going to multiply the top and bottom of this fraction by x minus 5. We're going to multiply the top and bottom of this fraction by x minus 3. So we do have to simplify this. Okay? All right, so I'm going to put x minus 5 over here, top and bottom, and then over here x minus 3. Okay? All right, so we're going to multiply this. So that's x squared minus 5x in the top over x minus 5, x minus 3, minus, multiply this out, which is 2x minus 6, over x minus 5, x minus 3. So now you have a common denominator, so we can add or subtract these. So remember, when there's a minus sign out here, you're going to subtract both numbers, so they're going to change signs. So this is going to become a minus 2x, and this will become a plus 6. So we can combine all that in the numerator. So minus 2x plus 6 over x minus 5, x minus 3. Simplify the top. So that'll give you x squared minus 7x plus 6 over x minus 5, x minus 3. And then we have to see if we can factor and reduce. So this will factor. It's not going to help us, but factors of 6 that add up to give you 7, I can factor that. So that'd be 6 and 1. So I end up with x minus 6, x minus 1 over x minus 5, x minus 3. And I can't cancel anything. There's nothing they have in common, so that would be my answer. Okay? All right, so now we're going to look at the domains of each of these. So the domain of f of x, all right, we set that equal to 0. X minus 3 cannot equal 0, so x cannot equal 3 for this one. For g of x, set that denominator equal to 0 and see what x can't equal. So if you set that equal to 0, x cannot equal 5. Okay. And now we're going to look at our result. Okay, so the domain of our result. Still, I can't use 5 and I can't use 3. So x can't be 3, x can't be 5. Remember, the numerator is fine. Those numbers can be whatever they want. It's just the fractions, the denominators. All right, so if I look at all this together, then I still can't use 3 or 5. So that's my answer. So negative infinity to 3, 3 to 5, 5 to infinity. So that would be the numbers that I would be able to use in that problem. All right, and in part B, we're going to take the same two functions, and this time we're going to divide them. Okay? All right, so we already know the domains of f and g. Okay, we don't have to do that again. I'll write it down. So all we really need here is the domain of the result. So let's see what we get. So this is g of x divided by f of x. All right, so g of x goes on top, 2 over x minus 5 divided by x over x minus 3. So remember, when you divide fractions, you're going to flip and multiply by the reciprocal of the bottom. So that's 2 over x minus 5 times x minus 3 over x. Okay. When you multiply, you don't need a common denominator. Just multiply straight across. So that's 2 times x minus 3 over x times x minus 5. Now, you can go ahead and multiply that out if you want to, but we need this so that we can get our domain. So I'm going to leave it like that. Okay. You can multiply it out. So if you wrote 2x minus 12 over x squared minus 5x, that is perfectly okay. Same answer. Okay. Doesn't matter if you do it this way or this way. All right, so we already know the domain of f of x, which was x could not be 3. We know the domain of g of x, which was x could not be 5. Now we have a new number here, okay? If we look at the result, okay, you set each of those equal to 0 and get your what x can't be. X can't be 0 here, and x can't be 5 here. Remember, you take each factor, set them equal to 0. So this is x can't equal 0, this is x can't equal 5. Okay. So, x can't be 3, x can't be 5, and now x cannot be 0. So now my answer would run from negative infinity to 0, then from 0 to 3, then from 3 to 5, and then from 5 to infinity. Okay, so I take out 3 numbers on that one. All right, so be careful when you write the domains. Those give you a little bit of trouble, so just take your time on those, okay? All right, example 3. Got 3 new functions, f, g, and h. Again, square root function for f, polynomials for g and h. Now we're just going to plug in some numbers and evaluate. So no more domains here because now I have a number here instead of x, so I can actually work that out. All right, so remember when you're adding functions, you can break them up. So we're going to find f of 7 and just add to it whatever the value of h of 7 is. All right, so we're going to put 7 into function f. So I'm just going to work that out here. If you need to write it out, you can, but we put a 7 in there. 7 minus 3 is 4. Square root of 4 is 2. Okay, then I'm going to put h of 7. I want to put 7 in function h, so 7 plus 5 is 12. So my answer would be 14. Okay, so you're just working these out. All right, f times g of 4 would be f of 4 times g of 4. All right, so f of 4. So you're going to put 4 in function f. 4 minus 3 is 1. The square root of 1 is 1 times. Then we're going to put 4 in function g. So just make sure you're putting it in the right place. So 4 times 4 is 16. 16 minus 2 is 14. 1 times 14, also 14. Okay. And lastly, h divided by g of negative 1. So we're going to do h of negative 1 divided by g of negative 1. So now we're going to put negative 1 into h. Negative 1 plus 5 is 4. We're going to put negative 1 into g. 4 times negative 1 is negative 4 minus 2 is negative 6. And we can reduce that down to negative 2/3. So you're just evaluating based on the numbers. All right, example 4, we're going to do the same thing, except you're going to have to pull the numbers off of a graph. Okay, so for part A, we need f of 4 plus g of 4. So remember, that means we're looking for the y values on the graph. So we're going to go to function f, which is the red line, and go to 4. So right here, we need that y value, right? The ordered pair is 4, 2. So at f of 4, the answer would be 2. Then we're going to do the same thing, go to function g at 4, which would be here. That's the ordered pair for negative 2. So g of 4 would be negative 2. Add those together. 2 plus negative 2 is 0. Okay. All right, for part B, f of 0 minus g of 0. All right, so we're going to go to 0 on f, which is right here. That's the ordered pair 0, 0. So that's 0 minus g of 0. That ordered pair is 0, 2. So again, when x is 0, y is 2. And 0 minus 2 is negative 2. All right, now we're going to multiply f of 4 times g of 4. Remember, when there's no sign in the middle, that's a multiplication problem. Okay, so again, we've already done f of 4. That was 2 times g of 4 we also did was negative 2. So that would give us negative 4. And lastly, we're going to divide f of 2 divided by g of 2. All right, so let's go to f at 2, which is right about here. So let's call that 1.5. Okay, that's the ordered pair 2, comma 1.5. So we'll put 1.5 here. And then divided by g of 2. Well, g of 2 is 0, right? That's the ordered pair 2, 0. So it doesn't really matter what's up here. We cannot divide, so that would be undefined. Okay. All right. So I'm going to stop there because that's all the information for just adding, subtracting, multiplying, and dividing. And then we'll start part 2 with compositions coming up next. Okay? So work on your homework or continue with your notes. Your choice.